Hello viewers, welcome to another episode on our Pillar Talk Maths. Today we shall be talking about trigonometry, and some of the areas we are going to emphasize critically today are basic trigonometric ratios, reciprocal or basic ratios, trigonometric ratios for special angles. Okay, now basic trigonometric ratios has to do with the sides of a right angle triangle. You can see our right angle triangle here. Now let's label our right angle triangle as this: QPR. In a right angle triangle, we have the longest side known as the hypotenuse. Okay, now we are going to designate this angle theta, and this is angle 90 degrees. Alright, the side that is facing angle theta is this side, so we are going to designate it as small letter p. Alright, adjacent to this angle is this side, and we are going to designate it with small letter q. Then the longest side of this right angle triangle is facing r, and we're going to designate it small letter r. So having known this, we are going to get the three basic trigonometric ratios such as sine, cosine, and tangent. We often use an acronym like SO, CA, TOA to assign these words basic trigonometric ratio. So let us know the value of our sine. Our sine here will be sine theta equal to opposite over hypotenuse p over r. Then cos theta will be adjacent over hypotenuse, which is q over r. And our tangent will be tan theta equal to adjacent. Okay, we have the adjacent, opposite over adjacent, opposite over adjacent, which is p over q. So these are the values. But recall that tan theta equal to sine theta over cos theta. So recall that tan theta is sine theta over cos theta. So let's prove this. Proof. We have that sine theta, when divided by cos theta, will give tan theta. Okay, so, and this is what? From our basic trig ratio here, we have p over r divided by q over r. Let's see whether it will give us tan theta. Okay, so when this turns, we have p over r equal to, that is, change the division to multiplication, times r over q. So this r cancels, we have this as p over q. And we know that our p over q is tan theta. So therefore, tan theta is equal to sine theta over cos theta. Case solved. This on the line is the reciprocal of basic ratios. Let us look at reciprocal of basic ratios. Okay, the first on the line is sec theta will be 1 over cos theta, and if we are using this ratio, it will be 1 over where is our cos theta? Our cos theta is q over r. So when this, we have r over q. Next is cosec. Cosec theta will be 1 over sine theta. And this should be 1 over, what is our sine theta? P over R. P over R. So we're going to have R over P. And another one is cot, that is cotangent. Cot theta will be 1 over tan theta. That is to say 1 over sine theta over cos theta. So if we work on this, it becomes cos theta all over sine theta. Okay, having not done this, we are done with the reciprocal of basic ratios. So let us move to trigonometric ratios for special angles. Trigonometric ratios for special angles. Trigonometric ratios for special angles. Now, we start with sine theta. Sine theta degrees is equal to 0. Cos theta degrees is equal to 1. Alright. Tan theta degrees is equal to 0. In the other hand, we are going to have 90, special angle 90. Sine 90 degrees is equal to 1. Cos 90 degrees is equal to 0. And tan 90 degrees is equal to undefined. Okay, having known these special angles, we start again with another special angle known as 30 degrees. 30 degrees. We want to talk about this special angle 30 degrees. Now, in this special angle 30 degrees is better solved with 30 degrees, 60 degrees, 90 degrees right angle triangle, which actually we're looking, if you look at it, it will appear in this form. It will appear in this form. Sorry. So, okay, we're getting there. Connect it. So, it will look in this order. So here is our 90 degrees. Here is our 30 degrees. Okay, if you look at it, the ratios and the sides are not equal at all. So this opposite will target 1, this longest will target 2. So remaining our adjacent. Adjacent we don't know. So let us get adjacent using the Pythagoras rule. When we use the Pythagoras rule to get the adjacent, we have adjacent squared equal to this will be 2 squared minus 1 squared. So this will give us adjacent squared equal to 4 minus 1. So adjacent squared will be 4 minus 1 is 3. Alright, so we can say adjacent squared equal to what? 3. Find square root of both sides. So this will be adjacent, that's missing side, is now equal to sod 3. Another way is saying sod 1 plus 2 multiplied by 1 will give us sod 3. Okay? Having not done that, the adjacent here is now sod 3. We can get sine 30 degrees. So sine 30 degrees, sine 30 degrees will be opposite over hypotenuse, that is 1 over 2 or 0.5. So opposite over hypotenuse 1 over 2. So that is how it is derived. Sine 30 degrees is this. Let's see. Okay, next will be cos 30 degrees. Cos 30 degrees will be adjacent over hypotenuse. Let's say adjacent over the hypotenuse. So this will give us our adjacent is sod 3 all over the hypotenuse that we have here is 2. So the value of cos 30 is sod 3 over 2. You can see that on the board. The next that we have is tan 30 degrees. Tan 30 degrees will go with opposite over adjacent. Opposite over adjacent. See our opposite. Our opposite is this, so we are going to have 1 over sod 3. We can actually leave it like this, or we rationalize. Rationalize the denominator. When we rationalize the denominator, we have tan 30 degrees equal to 1 over sod 3 times here by sod 3 times here by sod 3. So we are going to have sod 3 all over 3. So this can also stand in here. So we have treated everything that concerns special angle 30 degrees. The next on our agenda is special angle 45 degrees. So let us write it out here. Special angle 45 degrees. And in special angle 45 degrees, I will deem it fit to get something that will help us to rule this line. So we are going to have special angle 30 45 degrees. Sides are equal. Alright, so this is 90 degrees. These two angles are 45 degrees. 45 degrees. Okay, from here, remember we're looking for the cos 45 degrees, sin 45 degrees, and tan 45 degrees. So from here now, you can see that this side and this side are equal. So we give them what? 1, 1. Alright? So our hypotenuse will now be hypotenuse squared equal to 1 squared plus 1 squared. Alright? Hypotenuse squared equal to what? 1 plus 1. Hypotenuse squared equal to 2. Find square root of both sides. So the hypotenuse is now what? Sod 2. So here will be sod 2. Okay, now that we have that place noted, we go over again to this side. Alright, let me erase this part of the board so that we can have space to complete our task. Alright, done justice to this side by erasing it. So what is left now is for us to get the various special angles for 45 degrees. So we'll start with sine 45 degrees. Sine 45 degrees happens to be opposite over hypotenuse. So we have our opposite over hypotenuse. Looking at this, the opposite here is 1 and the hypotenuse is sod 2. So if we rationalize the denominator, we have 1 over sod 2 times sod 2 over sod 2. So we have sod 2 over 2. So this becomes what we obtain. Sod 2 over sod 2, or sod 2 over 2. If you don't want to leave it in 1 over sod 2, you rationalize the denominator, you have what? Sod 2 over 2. That is for sine 45 degrees. I believe we are making progress. So next is cos 45 degrees. Cos 45 degrees will give us adjacent over hypotenuse. And our adjacent from what we have there is 1, and our hypotenuse is sod 2. Apparently it will give us what? The same thing as sod 2 over 2, or we leave it as 1 over sod 2. Okay, let's see if there will be any difference in tan 45 degrees, since cos and sine 45 degrees are giving us the same thing, sod 2 over 2, or we leave it as 1 over sod 2. So we go to tan 45 degrees. So tan 45 degrees will be opposite over adjacent. And if we look at that 45, 45, 90 degrees isosceles triangle that we have here, you will see that the opposite is 1, the adjacent is 1, so we have 1. So the answer to this is what? 1. Okay. So tan 45 degrees is 1. So far so good. We have come across the special angles, and we have treated the sine theta, sine 90, cos theta, cos 90, tan theta, and tan 90 and their values. We have also talked about 30 degree special angles. You know the value of cos 30 degrees, sine 30 degrees, and tan 30 degrees. Same thing happens to 45 degrees. So the last but not the least is going to be 60 degrees. So we are going over to 60 degrees. We want to handle this. Okay, I will be needing the help of this to get my right angle triangle. All right. Okay, if we look at this, you will see that it is more or less like the 30-60 degrees right angle triangle that we drew before, but this time around something have to change. All right, our adjacent in 30-60 will now be our opposite. So we have some 3 here, this angle 60 and this 30. So the hypotenuse remains 2, and the opposite in the other one becomes the adjacent. Yeah, so we have 1. Looking at this, to get our sine 60 degrees, sine 60 degrees will be opposite over hypotenuse, and our opposite is sod 3 over 2. So this is the value of sine 60 degrees. Okay, I will be erasing this part of the board to help us complete our task today. Erase this part of the board. So next one is cos 60 degrees. Cos 60 degrees will be adjacent over the hypotenuse. And we look at this, our adjacent is 1, our hypotenuse is what? 2. So for cos 60 degrees, we have 1 over 2 half of 0.5. Okay, and the last but not the least will be tan 60 degrees. Tan 60 degrees, opposite over adjacent. So this will give us the opposite that we have here is opposite that we have here is sod 3 over 1, which is actually sod 3. Okay, so far so good. We have completed our task for the day, and I would like you to go over this video over and over again. If you have any questions, please do ask your question in the comment section, and I want you to help me share this video. Okay, click on the bell icon so that you'll be notified whenever I upload new video. I also urge you to subscribe, share. Thank you, and remain blessed.